Hi, this presentation is called Using the R Interface in SAS to Call R Functions and Transfer Data. I'm the presenter, Bruce Gilsen, Federal Reserve Board, and here's my bio, which I'll leave for a moment. Okay, introduction. Well, first of all, this is a 50-minute presentation that we've compressed down to about a 20-minute presentation for this format. So I would urge you, if you want more detail, to go to the paper that's going to be published in the conference proceedings. It will follow the same narrative flow as this presentation, and you'll see the things I'm going to omit that you can find in the paper for more details. Okay, here we go. This interface is for Linux and Windows SAS users starting in SAS 9.2. You can call R functions from within PROC IML and get results back, and you can transfer data between SAS and R, either between a SAS data set and an R data frame, which is what schematics used to do, or possibly an IML matrix and R matrix if you are so inclined. And you'll be able to copy R data into the R interface with standard R functions. You'll be able to save R data from this interface to files with standard R functions, and you'll be able to call R. It's calling R from within SAS, not the other way around. You're a SAS user inside of SAS. You're calling this wonderful R interface. Now, who are the potential users? Well, the first group is PROC IML users, and I know there might be a few of you out there, but that's not the focus of this presentation. The focus is for people who are not IML users, which is most of us, but you've got IML license at your site. And that in order to do what's in this presentation, you must have PROC IML license at your site. That's really important. But if you do, even if you basically know zero about PROC IML, you can use PROC IML just as a wrapper to transfer data between SAS and R and call R functions and get the results back. And again, I'm going to focus on those of us who are not IML users but have IML license. Okay, why would I do this? Well, we live in a component world. There's SAS, there's R, and other languages, and the ability to work in both is something that's increasingly important. We may want to use R data as input to a SAS program. We may want to export SAS results to R for further processing. I think perhaps one of the biggest uses is as follows. Because R is open source, what often happens is there's an econometric journal article or a statistical article, and some new wonderful technique gets put out there and gets talked about. Well, if that happens on Friday, by Monday, somebody somewhere will have an R routine to do it. Now, it might not be robust. It might not work all the time. Might not always get the right answer, but caveat emptor, it's out there and it's available. Now, SAS, on the other hand, is a mature language. For them to introduce a new econometric technique is going to take some time. They're going to have to develop it, test it, do QA, integrate it into SAS, so on and so forth. That's going to take a while. You want to use this new technique now, but you're a SAS user. What do? Well, you continue using SAS, but you reach out to R using this interface to use this new technique, and you go about your work. I think that's going to be a major reason why people do this. Now, what are your system requirements? Most of us, I assume, are running SAS 9.4, but you have to have SAS 9.4 or later on Linux or equivalent or Windows. You have to have SAS IML software. How do you know if you have SAS IML software? You can do prop set init, semicolon, run, semicolon, and see if you have it or not. It lists out all the products. You also have to have a lot. Now, how to configure. There's a little bit of configuration work on Windows and Linux. They're a little bit different on each, but we don't have time. That's going to be in the paper. I'll leave that to you. Okay, here is the informal syntax. Now, I should point out that we're going to make this simpler, so don't worry if this looks scary. It's going to be much better than this. We bookend it with PROC IML, starting in PROC IML. We have the option for those people who are IML users to do IML statements. There are two functions that copy data to R. Call export data to R, which is for data, copies a data set to a R data frame, and call export matrix to R, which copies an IML matrix to R. And two functions that are absolutely reverse. Call import data from R, import data set from R, which copies a R data frame to a SAS data set, and then there's call import matrix from R, which copies an IML matrix. Copies an R matrix back to IML. And you'll notice, by the way, that those are not done inside what's called a submit block. You'll see that we have submit/r and r statement and r submit. That sequence there is called a submit block. That's where you place the r statement. Everything between submit/r and end submit is called, it's going to be submitted to this r interface to execute. Now notice that the functions that transfer data take place outside of the submit blocks. And you can have one or more blocks of code, of submit blocks. You can have one or more sets of statements that copy data back and forth, and one or more blocks of code that do IML. Now, since most of us are not IML users, let's strip this down and cross off all the things that are IML users. You can see that we've done that. Now, we're left with something much simpler and easier for the rest of us. All we're doing now is we have a PROC IML and a quit statement to book in. We've got optionally call export data set to R to copy SAS data set to R data frame, or call import data set from R to copy R data frames to SAS data set to as many of those as we want. And then we have one or more submit blocks. So this is really simple now. And you can see that even though you're not an IML user, if you have IML, you're just using it as a wrapper. Okay. Now a little bit of detail, and then we're going to do some examples. Okay. At any moment in time in R, there's a current working directory. And by default, it's the temporary SAS work library. You can check the location of work with the PROC option statement as shown. Anything that you wish to have persist after the session, you don't want to put in the work library because that will go away at the end of the SAS session. So you could, in R and in this interface, modify the working directory with setwd as shown on this slide, and that change will persist across submit blocks for as long as the IML session is going. Okay, more generally, let's briefly mention persistence. This R environment that we're creating in the submit blocks, you can have multiple submit blocks, but everything that's in there, any data frames you created or copied or whatever, are going to stick around until the IML session ends. And if you create plots, they'll stick around till you explicitly close them or the IML session ends. But we mentioned in the previous slide, the current working directory is preserved. Now, if you want to end IML but keep some of the R data that you've got in the R session, you can use, if you want to do that, you can either do SAS import, you can use in SAS, outside of the submit block, but inside of the IML session, you can use import dataset bar, which we talked about before, to copy an R data frame to a SAS dataset, or inside it, remember that inside this submit block, we're just doing R work. So we can use one or more standard R statements to copy one or more R objects to a more permanent location with save RDS, save, or save.image. And these are standard R commands that we can use like any other standard R command inside of this interface. Now, there's a gotcha with saving an entire workspace, but we don't have time to talk about it. There's a workaround. It's in the paper. Okay, simple file path limitation issue. If you are in Windows, you're used to using backslashes for file paths. That will not work. I guess it doesn't work in R. It won't work in this interface. So instead, you can use a / or you can use a double backslash. Now remember, if you think about it, when you're using an URL for a web page, you're using a / even if you're in Windows. So I guess it doesn't seem so strange that using a / would work here as well. Okay, a little bit about data transfer details. Missing values, dates, times, and date times, and variable names. Okay, missing values. As you know, in SAS, there is the dot, and there's a dot A to dot C, and there's dot underscore, and all of those are converted to the R missing value NA, and then when we go from R to SAS, the R missing value NA is converted to dot in SAS. Now, date times and dates and date times. Now, as you may know, a SAS date is the number of days before or after January 1st, 1960. It's an integer value. It's just this numeric variable in SAS where 0 is January 1st, 1960. 1 is January 2nd, 1960. 2 is January 3rd, 1960, and so on and so forth. And SAS time values are just the number of seconds since midnight on a given day. and SAS datetime values are just the number of seconds, the big number, before after January 1st, 1960. Now, when we employ these in SAS, strictly speaking, it is not required that we associate formats with them, and there are specific formats associated with dates, times, and date types. As a practical matter, we end up having to use them because if we don't, for example, as shown on the slide, if we say put date 1 and there's no format, it's just going to print the May 8th, 2018, it's going to print 21,312. So inevitably, for practical display purposes, we associate formats like datetime or my personal favorite, YYMMDD8. There's many, many others for each of these things. Now, when we get over to this interface, it becomes essential for correct processing to associate formats with dates, times, and date times. And the reason is that when we copy SAS data to R, the interface is going to look at the formats to figure out what the thing is. And in what it's going to do in R, classes are going to represent dates and date times. So when the transfer takes place, when we copy SAS data sets to our data frames, if it sees a date format, it's going to give it a class of date. And if it sees a time or datetime format associated with the variable, it's going to put it into the class of POSIX, CT, and pseudo-class POSIX X. I'm not sure what that means. One thing to note is that there's no real concept of time values in R. So what they do there is they just make the time into a datetime value with a start date of January 1st, 1960. But the key is you have to have formats on those date, time, or datetime variables in order for the interface to understand when you copy. When you go the other direction, R back to SAS, when you copy in our data frame, it will assign a format based on the class of R. If the class is date, it'll put date 9 as the format as to the SAS date variable when it comes back to SAS. If it's got POSIX, POSIX T, it will make it a datetime 19. Otherwise, no format. And let's talk about variable names. Any variable that's valid in SAS, any variable name is valid in R. However, R variables could have a period, which SAS won't like, or the variable names could be longer than 32 characters, and SAS is unable to handle that. So when import datasets R copies a data frame back to SAS, it's going to do two things. It's going to convert periods to underscores. That's pretty easy. And then it's going to truncate any names longer than 32 characters down to 32 characters. At that point, it's going to check and see if there's any duplicate names caused by this. And if so, there's an algorithm that it goes to create unique names that I don't have time to discuss, but it will make the unique names. Okay, we've given all the background. Now let's look at some simple examples. And first of all, our simplest example, the first one here, is just kind of a proof of concept. We're not going to transfer any data. We're just going to do the same work in SAS and R just to show you how it would work. So first, on the left-hand side, in SAS, we're going to do a little data step to make a data set, and then we're going to do a PROC means to get the name. On the right-hand side, we're going to do the same thing with this interface. We're going to use PROC IML and quit as bookends. We are going to do a submit block that starts with submit/R. We're going to create a object called X. We're going to take the mean of X, and we're going to print the result. And then we're going to use end submit to end our submit block. And that's all we're going to do. There's no data transfer or nothing, just basic stuff. And you can see here that happily, both PROC means and the mean function in R that we've gotten to this interface are going to return the same value, 22. Okay, example 2, just to show more of the nuances of data transfer and show the things we talked about earlier. We're going to make a SAS data set. We're going to copy it to R with the export data set to R routine. We're going to look at missing values, dates, and funny names. And then we're going to do various functions inside of this interface to show what our data looks like. And then we're going to copy it back to SAS with import data set to R and look at those as well. Now, I do need to point out one little sort of cheat that we're doing here. In real life, when we use this interface, all the output that we generate is going to go contiguously into either the output window interactively or the output file. Here, what we're going to do just for educational purposes to help see what we're doing is we're going to interleave the output as it gets generated by the statements. And that, again, I'll show you the data sheet out there really quickly what the true output looks like, but I want you to see what the implications are of each of the steps that we did. Okay, here's our SAS data set. We're just going to do a little data step here and make a SAS data set with a few variables and a few observations. Note that the last column, date 1, is a SAS date, the format of YYMMDVN8. Note that in our last observation, that text is a missing value. Okay, now we start PROC IML. We copy data set 2 from SAS to our data frame IML2 with call export data set to R. Now we start a submit block. What we're going to do is we're going to create a new column in this data frame called IML2 called net income is the name of the column. And if we do the names function, we can see that we've added it. There's now 4 columns in the data frame. If we do a print, we can see that the date variable is in fact understood to be a date. You can see that we've added a new column. You can also see that the missing value of dot in SAS has become the missing value of NA in R. And here we just print one of the columns. We take the class of one of the columns. We can use the stir function to get information on the column. These are all things you can do. Remember, we're just doing standard R processing. It was just information. And then we're going to use the summary function to get even more information. And presumably then we would do some actual real work. Let's enter submit block. Then we're going to do call import data set from R to copy the data frame IML2 back to a SAS data set called from IML2. Then we're going to enter that. Now we can do a PROC print. Sorry, the columns on this few of these are slightly less than perfectly lined up, but that's okay. Should still be visible. So here in our PROC print, you can notice a couple of things. First of all, the date column is in fact going to be a SAS date in SAS with the datetime format as we talked about. You'll notice that the NA missing values in R are dot in SAS. That word net underscore there, top of the thing got spilled over, but it should have been net underscore income. Remember that we had a variable in R, column in R called net dot income. Dot's not a valid SAS name, so it replaced it with an underscore, and it's now called net underscore income. So you can kind of see the mechanics of data transfer. And here would be the actual non-interleaved output you would see in the output window or file. Okay, now on to example 3. This is more like what we would actually do in real life. We would have, now I'm just going to demonstrate this with OLS regression, which of course SAS as well, but you could replace that here with something that's in R, some statistical procedure that's not in SAS, and it would work exactly as shown in this example. We're going to copy SAS data to our data frame, run a regression in R, then we're going to return the results. Okay, so here is a data step that's going to create a SAS data set called class with about 20 observations and a few variables. Now, just to illustrate, we'll first do PROC reg in SAS. I will show you the output. It's pretty basic, nothing too exciting. Then we're going to start PROC IML. We're going to copy this data set called class using export data set to R to an R data frame called class 1. Then we're going to start a submit block. Then we're going to use the function at the bottom of the screen to do ordinary least squares regression. That's standard R code there, nothing special. Then the next thing we're going to do is we're going to extract from the results of that regression some values, the parameter estimates, the predicted values, and the residuals. And then we're going to print them. So you can see that having done the regression in R, we can, in R, in this interface, we're just going to extract values that are the results. Then what we're going to do is end our submit block, and then the interesting part is we're going to copy the parameter estimates from the object param_est in R into a SAS data set called PE. And then we're going to end PROC IML. Now, why did we do this? Because we wanted to run this new exotic regression technique in R and get some results back to SAS so we could do some further processing. This is exactly the way I think people likely to use this interface in one way. So now we can see here, if we do PROC print, we can see what this PE data set, which has the parameter estimates, looks like. And then SAS, we can continue with our regular analysis and just be SAS users again. And you can see here that what I've done in this example is I'm using the parameter estimates that I calculated in R and brought back to compute predicted values for some heights. And this is, again, the type of thing I think people will do. And we go ahead here and run our data step, or we haven't done anything, but here it's just a data step. And we're going to generate some new results. And then we do a PROC print, and we can see the results. So again, just to review, because this is, I think, kind of the essence of the whole thing. We were in SAS, we sent the data set over to R, we did some statistical procedure, we pulled out some results from procedure, we sent those results back to SAS, and then we went about our business in SAS. Really pretty nice and straightforward. And here's the actual raw output you would actually see. Now, example 4, we're going to skip. This is a more complex one where we do things like pull our packages and do our graphics. We can skip that. It's in the paper in detail. Next one, source file. It's very possible that you're going to have R programs that are sitting in files that you just want to run. If you're a SAS user, you're familiar probably with the idea that you do %include, and you bring in a SAS code from a file, and it's as if you have keyscoped it right there, and it will run it. The source function in R does the exact same thing, and you can use it right here in this interface to bring in R code from a file and run it. And I've got an example there of how to do it. And this is how you can use programs that you've written and run them within this interface. Okay, last example. This is just going to show you the mechanics of copying and saving files. Let's just say that at first you work in R and you do a bunch of things. I will go fast here in the interest of time saving, but you're going to work in R and create a working directory, create some objects, save them, and then so you do that or somebody else does that, and then we're going to go into SAS and we're going to work with these files. So let's start in R. We're going to use setwd to set the current working directory. We're going to create two objects, object 1, object 2. Then we're going to create a data frame containing those two objects. Then we're going to save object 1 using save RDS, which is a standard R function for saving a single object. Then, just to illustrate the difference, we're going to modify object 1 by changing the values in some cases. And then we're going to use the save function to save both object 1 and object 2 to a file. And then we're going to use save.image to save the entire workspace. These are save RDS and save.image are standard R functions that we can use to save objects or the entire workspace. My R expert friend reminds me to always say that save.image should be used carefully because if the workspace is very, very large, that could create a big problem at some point. So we've done this in R. We're not even in SAS yet. Now we go into SAS. We started to manipulate. We changed we used setwd to change the working directory to be the one we were using in R. Now we can start retrieving objects that we created in R. Now you'll notice that above each of these blocks of statements, I've got a commented out little block of code that shows how I generated them in R on the previous slides. You can see how we got it. So first I'm going to use RDS, read RDS to bring back object 1. That's the mirror image of save RDS. And you can see I printed out. Then I'm going to use the load function to bring back the two objects that I saved with the save function. That's the mirror image there. And I'm going to print them out. You'll notice that the values of object 1 reflect the change I made to them in R between when I did save RDS and when I did save. And then last but not least, we're going to use the load function to bring back in the entire workspace, which is, again, the mirror image of save.image. And now I've got everything back that I was now here in my SAS environment at everything I had when I was working in R in that environment. And then I could use a library function just like in R because I need this library to get the mutate function. I could add a column to a data frame with the mutate function, print that out. And then once again, I'm now done in the SAS interface to R, but before I leave, I might want to, or somebody else might want to look at this data at R. I can once again use save and save RDS and save the information here out to files so that they'll be available to me or somebody else in R. And I'm going to do save RDS, save and save.image, and then I'm going to end my submit block and quit. And again, this is just an example of panic signals. And here's the actual output that you would see in real life. Okay, conclusion. Well, this R interface, it's for Linux and Windows SAS starting in SAS 9.3. You're sitting in SAS, if you're not sitting in R. It lets you build, if you have PROC IML license, you can very seamlessly run R stuff, call R functions, get the results back, transfer data back and forth. The important point is also that while a few of you may be PROC IML users, you don't have to be. As long as you have PROC IML license at your site, you can use PROC IML just as a wrapper to transfer data, to call our functions, and that's really what this presentation was really about. It's this interface. You have IML, you're not an IML user. So, thank you. Here is my contact information, and feel free to contact me with questions. Thank you very much for your time.